Angular signals were introduced in Angular 16. Prior to signals, Angular uses Zondo.js. So Zondo.js intercepts all asynchronous events like clicks, timers, HTTP calls. So when anything happens, Zondo.js performs a top-down component tree check from the root down to find changes. Now, signals, on the other hand, what they do is they offer us a more targeted, granular reactivity in the sense that they only update the specific parts of our UI that is tied to that signal. So, in this tutorial, we're going to do a little introduction into signals. And then we are back on Angular website. And then here it says Angular Signals is a system that granularly tracks how and where your state is used throughout an application, allowing the framework to optimize rendering updates. So we might think of our state as some kind of data, or what is it called, or a a collection of data and properties that tells a story about the condition of our application at a specific point in time. So here we have, say, what are signals? A signal is a wrapper around the value that notifies interested consumers when that value changes. The signals can contain any value from primitives to complex data structures. So primitives are data type in JavaScript, numbers, string, booleans. Then for complex data structures, we have array, object, maps, and the likes. So we read a signal's value by calling its getter function, which allows Angular to track where the signal is used. So down here it says we writable signals provide API for updating the values directly. So we create writable signals by calling the signal function with the signal's initial value. And then down we have read-only signals. I think we have computed signals here as well. So we're going to be playing with some of this code to get a peek into some of the things we might achieve with Signal. So let's go back to our application. I have our counter application is running at on localhost 4200. This was from our previous tutorial. So we're going to implement some of these ideas in our code just to get a peek into some of the things that signals can do. So I'm going to go to app.cs, and then I'm going to delete this. So let's go here. Let's start with writable signals. So we can have so we can do something like count equals signal, and then it takes initial value 0. So we have to import this. So we import from Angular call like so. We could do increment, we could do decrement, things like that. So let's go back here. It says to change the value of a writable signal, here we do dot set directly. So we can do count.set, or we can use dot update operation to compute a new value from the previous one. So say we want to increase, can do increase count, Then with this we can do this dot count dot update, and then here we can take value, then we can do value plus 1, like so. Then for decrement we can do let's do decrement, and then here we can do this dot count dot update, and then we can do value, and then value minus 1. So this is going to decrement our count. And then for our reset, we can do reset, not what I have in mind, this dot count dot set, so we can set our count back to 0, like so. And what else? Let's look at computed signal. Perhaps we can do something like double count. We're going to come back to private read-only signal later on, but let's look at computed. Okay, I'm going to get this, and then I'm going to use it here in our component. So this has to go. We're in Angular, and I have to import this. Okay, so import, and then this generic signal has to be imported as well. So this is going to be this dot count. So that's going to handle our double count. Now for our template, let's do inline template here. Okay, so this has to go, and then here what can we do? Let's do h3, and then in here we can call this signal getter function. So we have count like this. So this display the current state of our count here. Now let's have some buttons that we can use to update our signal button. Let's use this. Let's set this to be as add. Then let's have some style. Let's have margin right. Let's set that to be 5 pixels. Background. Let's set background to, I don't know, is it green? And then color, let's set that to white. I'm going to copy this, and then I'm going to paste it down here. One more. Okay, because we would like to have reset as well. So here for decrement, let's what should we call this? Gray. Okay, let's use gray, and then here let's use blue for reset. Blue, and that's the last button. We don't need this margin right. Okay, so whereas for our double count, let's use h3 as well. No, h3, and then in here double count, like so. We have to perform some click events here. So here we can have click, and then we set this to, I think this is increase count. Okay, so that's increase count, and then this is I think this is decrement. So we also have a click event here, click, set this to decrement like so, and then this is just going to be a reset. Click, and this is going to be a reset like so. Okay, now let's see whether this works. I'm going to save. Okay, so yeah, okay, so now we have this. For the reset button, this should have been reset like so. I'm gonna save this. Okay, so we're back here. So if we do increment, okay, so that's working. So we're getting the double count here. Oh, perhaps I should just do something like this. Here could do current count, and then here we can do current double count like so. So this put things in proper perspective. So if I increase one more time, we're getting it twice of this. So I can also decrease like so, and then reset back to 0. So that works. Now let's look at read-only signal. What we have here, say converting writable signals to read-only. Writable signal provided as read-only method that returns the read-only version of the signal. So this is useful when you want to expose a signal value to consumers without allowing them to modify it directly. So to implement this, we're going to create a service. So let's go here and let's do counter.service.cs like so. And then here we're going to do import injectable. Okay, let's do injectable, and then here we can do the decorator injectable, and then what is it called, provided in root, so that will tell Angular that we're going to make use of this in the root of our application. What else do we do here? Let's do export class counter service. Okay, and then in here, what do we have? We have this. So I'm just gonna copy this decrement. Okay, and then we're going to adjust with respect to Angular. Okay, so we have to import signal. So this get imported. Okay, so read only counts. It's a public read only. We're going to make use of this when we perform our dependency injection at the point where we inject this counter service. This count is going to be available for us in that component. So this is increment. We can do decrement. So this is going to be this dot the private property count dot update like so, and then you can have v and then v minus 1 like so. For the reset we can have what is it, this dot underscore count dot set back to 0, and then for double count I think for double count, we can have double count, double count, Signa. No, I want to use a Signa generic. So that's number, I think, number. Whereas you can set this to computed. Computed. Okay, so we have to import this as well. Import, okay. And then here we have much like we did the other time, it takes a callback, and then we have this dot underscore counts. Okay, this dot underscore count and multiply by 2. So that's double count. Now we have to inject this service in our app.cs. So to do this, I'm just going to delete all of this, and then we can do state equals inject, and then we have to do counter service here, counter service, so that gets imported. Now for our, so we have increase count. I'm just going to change this to increment, so that it's consistent. So here we can do increment, and then here let's do this dot state. Now this state is it's pointing to our counter service. So this is dependency injection. Inside our counter service, we specify with this at injectable decorator that this is going to be injected in our application. So when we get here, we're using this inject method to inject our counter service, or is the inject function now. So the state property here, it holds our counter service, so it points to our counter service here. So we can do this dot state dot increment. So this increment is the increment function that we have here. So let's go back. We can do decrement as well, decrement, and then here we can do this dot state dot decrement, and then for what is it got? For our reset, we can do this dot state dot reset. Okay, so that works. Whereas I think we have double count here. Okay, we have double count. I think we can just do here. If I do double count, I don't know, double count, set this to this dot state dot double count, like so. Now we have to make use of this in our components. Okay, so we're going to persist with this. Current count is count. Now this count is not inside our component here, but we have it as public read only here, this one. So public read only, so we can make use of this inside our app.ts. but we cannot update it inside this component. So whatever updates we're doing has to come from our counter service, but we are allowed to make use of it here. So this count is coming from our counter service, and then increment, decrement, reset, double count as usual. So let's save and let's see whether this works. Okay, we have an issue here. Say the property count does not exist on type app. Okay, I think I should have done count equals this dot state dot count. Okay, so that should work now. Apologies for that. Okay, so let's see. All right, let's go back here. So we have application as usual. So when we do increment, okay, so we're getting a double count here, and for the decrement, it's decrementing as well, and reset goes back to 0. So guys, this is an introduction into Signa. When we return for our next video, we're going to implement component communication using Signas. So until then, guys, stay tuned, and then like, share, and subscribe. I'll see you guys.